Welcome, everybody, and thanks for joining us on this new subject for Kowa webinars, astronomy. We've got Martin Tomas here. I think he's probably one of our most used ambassadors. You know, you've done quite a few webinars for us now. We've done snow leopards and various digiscoping webinars. So really appreciate your time again, Martin. And normally you would see our colleague Jeff from the US hosting the webinar, but he's over at Columbia Bird Fair this week, so he can't join us. But he's here in spirit, I'm sure, and he'll watch the video, and we put it on our YouTube channel, which we always do after the end of the webinar. So if you've got any questions, you can put them on the chat. There's two Kowa colleagues, myself and Paul, will be in the background, and we'll direct your questions to Martin. So if you've got any inquiries, just drop us a message and we'll get them over to Martin. So yeah, once again, Martin, thanks for doing this. I'm really interested in this myself, astronomy, and I have no idea what you're going to present. And you know, I've only scratched the surface. So yeah, really looking forward to see what you're going to present for us. So I'll hand the reins over to you.
Okay, thank you, Rob. I will share my presentation. I hope everybody can see it. And let me begin that the astronomy is a huge area. So I will not focus on every little moment. But let's say my goal or my target is to present you how you can start even with your, let's say, not astronomy dedicated scope or binocular, and how you can enjoy it, because some people are saying the space or universe is infinite. Maybe it is, maybe it's not, who knows. However, it's definitely infinite portion of some inspiration and nice objects, which, let's say, will be everywhere every night for you if you will have a clear sky. However, I will start with some funny picture I made. I think it was in Serbia when I was traveling to my favorite destination in Eastern Europe. If it will be work, yes. And it definitely shows that there's some God in the sky, because I make this photography when God was trying to fix the moon. So now everybody who is, let's say, more skeptical about this, let's say, existence now has a very hard data answer. But after that, there is one even more important question concerning astronomy or astronomical observation. Is there any life in space? I'm not using my favorite Kahoot to ask directly you and to have some let's say voting pool. But I decided, because the presentation could be long, then to answer for you. I'm sure there is a life in space. For now, these are these 10 gentlemen. Oh, sorry, no, not only gentlemen. I see two ladies in the middle. One is even looks like lady, one is more the KGB look. However, there are like 7 people on ISS, International Space Station, and 3 Chinese in Tiangong space station made by China. Finally, we already talked with Rob that it's possible to spot ISS very easily if you will use some application which has a database of, let's say, flights, ISS, over your head. You can get the information, what time and what date is perfect for you, and you can see it. It's pretty visible on the sky. Yes, for sure, it should be clear sky. And to not forget, I think these not so known for many people here, but this one member of the, let's say, the space public is very well known. So be careful. Keep your cats out of this very special alien. And if you will make a picture of him, you can put it to your TV shows, or share it on the internet in some astrophotography groups. And I think you will be very famous in a while. But back to the seminar from jokes from the very beginning, because I don't know if everybody knows me as a person from my last Himalayan scoping seminar webinar or the old scoping webinar. I am a human being, yes, Homo sapiens sapiens, located in Prague, is in Czech Republic, exactly in Milky Way. I don't know what the postcode Milky Way has. I'm a wildlife guide, so I'm taking my clients' people to wild and show them my animals and stars as well during the night. I'm a Kowa ambassador for 2 years, I think. My reach with hands, it's not my height, is 245 centimeters. And this is the answer for Robert. Reach with the Kowa scope, and I'm using mostly the Promener 99 angled, is 2932826446500480000. I think it's range like this, which is 293 quintillion kilometers using the Kowa equipment, which is pretty huge. And maybe your question is, what the hell is so far what you can see with a pretty small scope? I will show you. Even with the picture, I hope it's visible for you because it's pretty faint object. This is the Whirlpool galaxy, which has a number M51 in the Messier catalog. Messier catalog is one of the most famous lists of sky celestial objects. It was discovered in 18th century, and it has 8.4 apparent magnitude, and I will explain you what it is a little bit later. And it's in Huntington's constellation, if you like the Latin names, Canes Venatici. And this picture was made through my Kowa 99A using the mobile phone, Samsung Galaxy S22 Ultra, and the Expert RAW in it. And it was a 15 seconds exposure with ISO 800, and the bottle was 4, which is pretty good for Czech Republic. It was in Šumava National Park. Well, it's one of the last places with the bottle 4 skies in our country. So you can see, and yeah, and I should add, it's only, let's say, one photo is not processed like with stacking or something like this. I will talk about a little bit later. So if you remember, it was like a 390 quintillion kilometers far away. And maybe if I will try it in some, let's say, more darker skies, it will be definitely even more. But this is what I know, let's say, the farthest object I already saw through my Kowa scope. And how we will go through the webinar, this is our schedule. I will start with the cul-de-sacs or blind alleys, if you want. So we will talk about how to not fall into the astronomy, because I got the, let's say, many friends around me, which helped me pretty much when I, let's say, started to do a deeper interest in it, which made a lot of mistakes, or not a lot, but let's say 3 major mistakes, and I was prepared pretty much to not do so. And also, I did one thing very important for me, so I connected immediately with someone who has a, let's say, much bigger experience in that area, and discussed, I can say, even hours with him to not make stupid mistakes. Then I will focus on what is important if you want to have a good observation. And because we will focus on, let's say, the light astronomical observation, uh, which is good for everybody who wants travel and wants not to build, let's say, it's his own astronomical spot. And then we will have a little bit of physics or mathematics more, because I will show you how powerful your scope is, how you can get the information, how powerful it is. And then we will discuss also what you can see, because I already told you that I will explain you what the apparent magnitude or surface brightness is, and how you can use it in your astronomical observation. And then I made a list what helped me, let's say, to go really rapidly in, because for me the astronomical observation is, let's say, not something like a 20 years of experience. If I compare it with my owl or feline or snow leopard experience, it's pretty huge, it's long. However, in astronomical observation, yes, I did some, but let's say something which can provide me with pictures you will see, it's only, let's say, a short period, like 1 year and something. So I will let you know what helped me to make it very easy. And by the end, I will focus a little bit of for astrophotography, but astrophone scoping photography. So how to use a phone. I will tell you even something about the astrophotography as a, let's say, a bigger area of astronomical observation. However, for, let's say, complete astrophotography, it will be like a one big seminar for many times, many hours to explain everything, and it's not my goal for today. So let's start with how not to do, or how what to not, or prevent you to making mistakes. I think the most common mistakes when you start to look up is to have a wrong expectation. And I used for it the my picture from the M51, so the Whirlpool galaxy, and my picture you can see on the right side. And from the left side, this is a picture I took from the Hubble telescope gallery. So this is processed something from the, let's say, space-based photography equipment and space-based scope. So you can see there's a huge amount of details and so on. And this is very tricky for newcomers to the astronomy, because when they look and they are going through some NASA websites or astrophotographic websites, or even the newspapers which are talking about, for now, for example, for the C2022 E3 ZTF comet, they are, let's say, observing very brilliant pictures which are made with equipment they will never use for it. Okay, even if they will come, or if they will go for some observation from some smaller observation points, even professional one, visually they cannot see what they can see on such a pictures. So be careful if you are newcomers. If you want to start to look up to the skies, please do not accept such a colorful and very detailed things. In comparison, in the middle there is a picture made by my friend, which is very good astrophotographer. But for this picture, I think it took like 3 nights, and every night it was like a 3 and something hours of getting the data from the special camera connected to a pretty big telescope. And after that, it was like I don't know how many hours, but more than 20 or 30 hours of some processing of the data to bring out such a beautiful photograph of the same galaxy. And for your information, if you will look from the city, from the inner city, or even very close to some bigger city, and you will put uh, even pretty big scope up, maybe you don't even see the M51 galaxy, because it's so faint that it will be, let's say, eaten by the light pollution and all the, let's say, problems with the atmosphere and so on. So even for the visual observation, even the mobile phone photo is, let's say, much more powerful than our eye is. So please don't have a, let's say, wrong expectation, and don't expect like a if you will buy some scope, or if you will look up pictures like of the left side. I got the another example from you, which is with the planet, because usually all the, let's say, newcomer observers are starting with planets. They are pretty visible from every side, even in the cities, in the light polluted cities. And also the left part is very detailed picture from the Hubble telescope and processed from the Hubble telescope. Then in the middle is work of my friend. And by the end, you can see what you can get if you will put. I think this is pretty old picture from my. It's some older phone. put it on the Kowa telescope. So you can see the planet. You can even see the one of the Galileo's moons. I don't know which it is, maybe your or Europe. However, you can see the storm stripes on the Jupiter's surface, but don't expect like such details like you can see on the left side. So this is what you can get. And also, even here, with the optical observation, you will get even less information, less, let's say, details from the picture, because the phone, it's usually, let's say, making a picture like for 10, 15 seconds. I will talk about it later. And your eye is processing, let's say, like a online every moment again and again and again. So you will not see so much details with the naked eye for the visual observation. And because people are coming the people are coming to the observations, they are, let's say, frustrated, sometimes a little bit, sometimes even more, that they can't see what they thought they will see from the pictures on the internet. And they are doing the mistake number 2, which is, let's say, going to the shops. And yes, going to the shops can be even very good if the shopkeeper has information, have some experience, and can help him. However, they are, let's say, shopping from the internet without any consultancy, anything, and trying to get as much as possible magnification from their scope. So this is very common mistake. And problem is that magnification is magnifying everything what you see through your scope. So here you can see what does it mean if I magnify the picture of Neptune, but with all the problems because of shaky atmosphere, because of not good seeing conditions, which is there is not enough focus for it, and it was shaky because of the wind. So if you magnify something, you are magnifying all the problems you got, let's say, from your optical system to the object you are photographing, or you try to, let's say, observe. So we, let's say, more, how to say it, let's say, lower your magnification expectation and try to start from the completely opposite side. I started also with how can I get with the magnification with the Kowa and with other scope I got. However, to be honest, for last something like a 10 observation, I think I put only, let's say, the widest eyepiece on my scope. And for another scope, which is the Schmidt-Cassegrain, I put the widest eyepiece and reducer, which is even, let's say, reducing more the focal length and magnification. And why? Because it was much better observation, and I saw more things, and, let's say, more sharp, and it was really much better. So be very careful, and even if you fulfill the, let's say, very common rule that your magnification should not exceed the front lens diameter doubled. So if you got like a Kowa 99, it's 10 centimeters or 100 millimeters or 99. So the maximum magnification for the scope should be about 198, so almost 200 times. For, let's say, last year and something, I think I only twice made an observation with the 150 because it was so good seeing conditions. But I will talk about it a little bit later. So don't worry, you will not see the planet, let's say, the huge one or some object, and it's better start with the wider angle and to see more context. And finally, you will see in a while that even the sharpness and the quality of observation will go up with the wider eyepieces. And the last thing, if you got the, let's say, the bad experience with the expectation. You think the magnification is not enough because of your equipment is wrong. You are making very happy your dealers, and you are coming there and buying and buying and buying and buying and buying. And I found these funny pictures on the internet, especially the guy on the right side. This is very special. There was even a story that he rebuilt something what was for the animals or for something, and prepared this special house with the roof automated for opening, and there was a small NASA point to make the astrophotography. However, I checked the photographs, and I can easily say that some of my friends or known people which are using much less equipment are producing better photographs finally. So it's not about having the crazy amount of equipment for astronomy or observation or even photography. It's more important to use it, and more important to have it, let's say, as comfortable as you can. And this is now the, let's say, few hints how to do it, not how not to. And I will start with something which is very important from my point of view, that if you will have a easy settable and a very lightweight equipment, you will take it with you everywhere. And this picture is funny because you can see that I'm using the typical tripod. I'm using a usual head with no navigation or not automatic navigation. Is not the go-to head. And I think it's a Kowa 99 because I got the more scopes. And look, I announced this astronomical, let's say, evening for people like 2 hours before. And after 2 hours, I got success with so many young ladies in the one of the Prague parks. So you don't need to have a huge equipment, and you will attract ladies, guys. And what is also important, that you will not be limited if you will travel not only even with a car, but I know it. Even I will use, let's say, my other scope, which mount is pretty heavier than this Gitzer tripod, and I'm taking it with me from time to time. So it's, you have to have this tripod, then you have to have like 7 or 8 kilograms head. Then you have the Schmidt-Kessel grain scope, which is much bigger than the Kowa is. And if you have to go even, let's say, one floor on the stairs, one again, back and back to the car, from time to time, you are leaving it at home, and I'm taking only my Kowa with much more equipment with me and enjoying it much more. So uh, if you want to go, and if you are very active, and if you think you will go, let's say you are going somewhere by a car or even by plane and enjoying holiday somewhere, the lightweight setup is very important thing to do, and you will be very lucky if you will do so, and you will not invest for something what is heavy. The second very important thing is to find as dark as possible sky. And this is very problematic, especially if you are located in Europe or Central Europe, because for now, for example, in Czech Republic, our dark sky begins with level 4 on the Bortle scale, which you can see it's much less when you, in comparison what you can get if you will be in not light polluted area. And I know it from Himalaya when we are observing snow leopards, and the nights there are simply beautiful because there's no light pollution, no means zero, and you can see with naked eye something what you cannot see even in Šumava National Park, which is the best dark area in Czech Republic for sure. Uh, if you will search the internet, you will find some discussion about the light pollution filters. So if you will have, for example, the astronomy dedicated scope, you will have a possibility to put filter on your eyepiece. It's for now not possible for the Kowa scope. However, for the astronomical eyepieces, yes, if you will use the adapter ring. And yes, this eyepiece can cut some light signals you don't want to get in your observation. But I agree with all the more experienced colleagues that the best light pollution filter is a gas. So sit to your car and go away from the cities and check some place where you can have let's say observation without not only light pollution from the cities and towns, but also from the other light sources which are very common in populated places like in Europe or in United States. Um, I found such a map of the world, and you can see how polluted is North America, Europe, India, China, Japan, and so on. So yes, if you are lucky and you live in Sudan, for example, or in Brazil in Pantanal, and or in Patagonia, or in the middle of the desert of Australia, you are really enjoying the perfect view to the night skies. And I recommend you can even build your astronomical point with very huge, big equipment and look really far away from the Earth. However, if you live in the so much light polluted area, go lightweight and travel. This is the recommendation you can do. Later on, I will show you what I use when I'm traveling, how to find the best spot on the concrete place, on the specific place when I'm traveling to, but it will be a little bit later. And my advice number 3 is, let's say, to prepare or manage all the seeing condition you can. And there's one important thing I didn't know about it, or yes, let's say in some how to say it, uh, some intuitive way, I did know that there is something like a, let's say, eye preparation, because everybody knows it. If you will go out, for example, from some lighted place, and then you have to walk through the forest for like 5, 10, 15 minutes, you can't see almost anything, and then it goes better and better and better. How our retina and our eyes is going to used to the dark environment. And this is something very important for the sky or astronomical observation, because you are going to catch really every photon of the light you can. And yes, the scope can help you, but if your eye is not prepared, the eye has a adaptive, let's say, superpower, that it can have very, let's say, open aperture or even very closed aperture. Some scientists has measured it, and it goes from, if I will use the photography numbers, the F numbers, from f2.0 to f9. So this is like a many f-stops difference. And if you, let's say, put your eye to close the aperture to f9, you will definitely not see many things, even if you will observe in very dark place. So be very careful. On the picture, you can see we are using the red lights, and it's very easy to get some. And this is one of the most important things you have to do. And please don't forget, we are talking about the phone scoping or astrophone scoping. If you will use your phone, it's a little bit harder, because till now I didn't found any application which is switching your phone to red, let's say, mode at all. All the astronomical apps can do it. However, all the phone, for example, if you want to, let's say, make a picture, you are switching from the red mode of the astronomical application to usual mode, even shaded as much as possible. However, your eyes are affected then. So my recommendation is then to first enjoy visual observation. And if you get a time, if the object is not, let's say, leaving from the observable part of sky, make a pictures by the end of your observation. What is very important also, look at the object which are as high as possible in the sky. Why? It's very easy to understand, because this is the shortest way out of our atmosphere. And maybe you read about this somewhere, but the universe has, let's say, not much atoms of something. They are made by the black energy, and the black something. I can't find now the word in English. However, there's like only something like a 4% of atoms which can, let's say, move somehow and destroy your observation. However, our atmosphere is very thick. Okay, and if you want to observe it, and the atmosphere is shaking and it's moving, and it's like if you will look as the flowing uh, dark or muddied water and trying to find a fish in the river. So avoid observation of the, let's say, planets or stars or some DSO objects where are very close to the horizon, and focus on planets and everything which is pretty high up. So this is very, very good for you. And the last advice concerning seeing is, if you will pick up some place where you will build your tripod and put the scope on, uh, you will probably have some plan what you want to see. So you will know that you will observe the south part of the sky, or north, and so on. Put it on some place where you get some bushes, some nature, grass, forest, and so on, in direction you will observe, because this is the most stable environment concerning all the atmosphere atoms, and it will process the, let's say, the best opportunity to get something. We call it like a 5 second of happiness, which is something that you will observe like for 1 minute. You will look through your scope, and it will, let's say, change the shape, and it will be not as focused or not as sharp as you expect. And then after some time, like 20-30 seconds, it will come like 5-3-4 seconds, like very sharp view, and you will see even the red spot on the Jupiter with very small scope. And after that, also again back like a muddy and not focused and a little bit shaky. And this is what the atmosphere does. And you have to wait. And if you will go through or over some parts where the atmosphere is not changing temperature, and some heated air is not going up, so the atoms is not moving so much, you will have better chance to get such a section, such a few seconds prolonged, or better, or more often. So there are very common mistakes, especially if you are, let's say, doing astronomy from your apartments. If you put the scope on your balcony, and for example, your neighbors and so on are, let's say, heating, or usually people are heating their apartments, especially during the winter, there is a lot of shaky air going around the building, so it's also almost impossible to get the sharp view of the planets or any object in the space. Finally, if you will photograph the bird through the scope, through such a moving atmosphere or moving air around the building, you will not succeed even with the, let's say, something which is very close to like 10, 15, 20 meters, and it will be not enough sharp because of this air shakings. So find some places where you have bushes, grasses, or some forests. This is perfect. Not over the parking places which are concrete, because there are many change of temperature, especially through the, let's say, winter time, or time when the sun is heating it up all over the year. So this was about seeing. And now let's say a little bit of mathematics. If Rob will not stop me for some questions, because I don't have a, let's say, for now time to get it. Rob, do we have some question or not till now?
Sorry, I couldn't. My microphone wouldn't unmute for the moment. Yeah, we've got a couple of questions in.
Okay.
Yeah.
So let's go.
Yeah, one from Emmanuel. He's using a 11WZ on the 883, and he wants to know what is the difference between an astro eyepiece and the 11WZ. Any advice on a good astro eyepiece, and can he use the extender, the EX16 extender with the astro eyepiece? I know the answer to that one, and that's yes, but with obviously with the astro adapter. But yeah, any particular eyepiece that you would like, a go-to eyepiece?
Robert, I will answer it a little bit later. So this question will be answered in my presentation. So this is the question I will talk about like in 20 minutes, maybe.
Yep. And the other question was asking about the exact focal length of the 99. I don't actually know what the exact
in a while. I got it in a while. So I don't know who provided me from Kowa. Maybe it was Jeff. However, I get this information, so I will talk about it in a few seconds. Okay.
No problem. Okay, I'll mute again.
Okay.
Yep, thank you.
So let's go for the mathematic part, and we will talk about the focal length as well. Because now we will focus on the scopes, which is your, let's say, helping equipment to gather light. And this is the scope power. And here you get some mathematics, how you can get the information, how much, let's say, light in comparison with your naked eye you can get using your scope. But I will tell you something, we will core first about theoretical amount, and I will correct it in a while, a little bit later. So now you can see that the easiest way is, let's say, to divide diameter of your objective lens or front element of your scope with the eye pupil and make it twice. And these are the numbers you can get. I will start with the binocular, which is a little bit special. I start with the BD234XD, which is my beloved binocular, especially when I'm borrowing it for my clients. And because it's 32 millimeters, if you will use the calculation, you can get 21 times more light gathered by this binocular, but it's not let's say the final answer, because you have to add something like a 20% of let's say more amount, because you are using two eyes. Maybe there will be some question why it's not doubled. Yes, because our eyes are not working like a computerized system, which can, let's say, get it like this. And this is because our brain gets the information, and I get this information from the scientific research, which are saying that some people are saying, let's say, from 20 to 30, some very optimistic, even 40% more. And let's say the most common answer is something between 15 and 25. So I average it, and we are adding 20% for the, let's say, more light gathering if you are using binoculars. So you can see even with the small binoculars, you can have 25 times more light than in comparison with your naked eye, which is very good, especially if you are, let's say, searching for faint object like the comet 2022 E3 ZTF now is, especially if you got in the light pollution area. If you will have some good scope, and I will talk about Kowa, and I got many friends with 770 series, which is pretty favorite one. It is 121 times more. So you can see that it's pretty big jump up. With the 88 Kowa, which is the new one, very brilliant scope, you got the 158. And now you can see that the number is going, let's say, faster up. It's not only to add like a 1 centimeter, because yes, this is the surface of the circle. So this is going up much faster than if you will only add the centimeter. And for the Kowa 99, which is the biggest one, it's 200 times more light gathered in comparison with the naked eye. And because I'm using the Schmidt-Cassegrain telescope from Celestron, which is the 150 millimeters of aperture, it's 459 more, let's say, power to gather light, and very common telescope for, let's say, some experienced astrophotographer or astronomist is the Schmidt-Cassegrain with the bigger aperture, 235 millimeters, and it means 1,127 times more gathered light of in comparison with the naked eye. So these are pretty nice and pretty, let's say, promising numbers if you will have a scope out, but be careful because there are some light losses in the systems, okay? So we have to count also with the light losses, and I tried to explain to you what happens if the light when is going through your telescope. Let's say I will explain it to you very easily through the F numbers. You know, I hope everybody from the photographic equipment. And I will start with the F number for the naked eye. Naked eye in the dark. So with the let's say very open aperture, which is prepared, has the F number around 2. And if you calculate and I'm using Kowa 99, focal length is 583. This is the information provided by Jeff. And the diameter of the front element is 99. So you can easily calculate the F number if you divide it. So if you divide this 583 with 99, the number of the F number is 5.88. So this is, let's say, the speed of your lens of your scope. And 588 means that it's, let's say, not so fast lens like your eye in the dark. So you have to calculate it back. And if you will, let's say, easily to have an idea, it's not the perfect calculation, but to have an idea how many light you are losing. So you have to divide it back. So what's the difference? And the difference apply to this 200 not effective, but theoretical light gain you got. And the answer then is 71.5, which is very close to very exact effective light you can gather with the Kowa 99, even with the light loss calculated. Okay, I hope it is understandable. You can do it with your scope if your scope is not Kowa 99. I'll show you even my second scope, which is the Schmidt-Cassegrain 6-inch diameter of the focal of the front element, and the focal length of this Schmidt-Cassegrain, which is mirror. This is a reflector. This is the mirror-based technology. Is 1,500 millimeters, so 1.5 meter, because it's, let's say, jumping down and up in the scope. And the diameter is 150, which is pretty much more in comparison with the Kowa 99. However, with the long focal length, there's much more light loss, and the F number is 10. So in comparison, it's 5 stops less in comparison with the eye in the dark. So if you divide it again with this 459, and you can get the information that you got the effective light gain around 100. So I got this 91.8. So this is what you really get to your eye or to your mobile phone or any photographic equipment. So you have to talk about it. If you will put the extender, because this is very, very common. If you want to, let's say, observe some very distant object, the extender can help you because you will get the longer focal length. So then it will be easier. However, with the longer focal length, you are getting, let's say, the worse rate words ratio, and your F number is going also very close to 10. And then there is a bigger light loss, and the effective light gain or light what the scope is gathering you is not then a 200 like in the theoretical number of the Kowa 99 or 71.5 if you don't use the extender but only 42.5. This is very important to know, and I will continue with one good advice. What is decreasing the light gathering? If you will zoom on your eyepiece, or if you will extend the focal length or magnification, because these two things are connected together. So, for example, if you will use your Kowa 99 and you will put the TE11 2 series eyepiece, which is from 30 to 70 times magnification, as faint object you want to observe, as low you have to go with your magnification. So use the 30 and forget about, let's say, zooming in or zooming up to some higher numbers like 50, 60, or 70, because you will lose more light, and it can happen that the object will not be visible for you, especially if you will look for the comet. And let's say you will use some light polluted area in the town or around the town. It can really, let's say, hide your comet for your eyes. And the same story if you will use, let's say, adapter ring and astronomical eyepiece. Be careful, because the Kowa is more suitable for eyepieces which a smaller number of focal length, which means bigger magnification. And bigger magnification means also light loss, and huge light loss in comparison with the wide eyepieces with the higher millimeter focal length numbers. And it can also hide your observed object. So my advice is, if you will observe some planets like Mars, like Jupiter, like Saturn, like Mercury, like Venus, they are pretty bright. So you don't need to care, or Moon, you don't need to care about light loss, because you got enough light even in the center of the city to get good view. And you can put all the extenders or Barlow extenders for your astronomical telescopes. You can zoom on your eyepieces as you want, and you will be right. Okay. Maybe, let's say, the end of the zooms are not the perfect for the sharpest views, but let's say you can zoom like for 67, for example, and it will be still okay. However, if you want to look at the Andromeda galaxy, or even the M51, which is much dimmer, or something like this, or the comet now, you have to stay as open as possible. So try to avoid any light, any loss of light gain you got or you can get from your scope. So stay as open as possible. This is my advice. I would like to ask you, Robert, if we have some question now for it to explain it exactly in the right time.
Nothing new at the minute. So,
Okay.
but I think you've covered the two that so far. Yeah, great.
Okay.
Thank you.
I try to build it as understandable as possible,
Yeah.
because
Yeah.
it's a little bit more physics than let's say usual astro lover or nature lover is doing every day. So now one, let's say, other information or other know-how you should know about what you can see and how you can gather enough light to see it. This is the print screen from my SkyGuide software from the computer, and on the print screen you can see a lot of, let's say, information, and I will tell you these information or these comments are comets which are visible if you look on a particular time. It was yesterday, 6:30, I think, from my apartment, if I will look to southeast, and you can count with me, but it's more than 50, okay? But if you use any scope, let's say any semi-professional or let's say scope you can get from the astronomical shop, it will be hard for you to find even one which is, let's say, squared with the red lines, which is the now most famous C 2022 E3 ZDF comet, the Neanderthalensis comet, or the green comet, and it will be hard for you, and the other will not be visible because their light is so faint that you cannot get it even with the scope, which will be, let's say, 14-inch diameter aperture and so on, even bigger. And now I will try to explain something what it's called apparent magnitude, which is one very special discipline, which is not, let's say, from the basic of physics, but it was let's say, try how to describe how visible will be some celestial object from the Earth, okay? So this is not describing the power of the object itself. I got the one example for you. The Deneb, which is the pretty big stars in the Cygnus constellation, so the Swan constellation, is 200,000 times higher brightness than our sun, because this star is huge. However, this star is pretty far away. So from our planet, from Earth, has a apparent magnitude, so how we see it, with number 1.25. And I will tell you something, the lowest the number, or the lower the number it is, it's more visible for you. So for example, our sun from our planet, from Earth, has a apparent magnitude minus 26.83. So which is very, very easily observable object. Everybody knows, nobody wants to look directly into the sun. If we compare it with the full moon, we get like a few days ago, the full moon has an apparent magnitude minus 12.74. But be careful, it looks like it's only twice less bright, but it's not true because it's logarithmic. So let's say every number of difference in apparent magnitude is, if you will, do it like 25 times. So if the difference between sun and the full moon is 14 magnitudes, apparent magnitudes, you have to 14 times make it 2.5 times, 2.5 times, 2.5 times, 2.5, and so on and so on and so on. And the result is that our sun is 372,000 and something brighter than our full moon is, okay? So this 14 magnitude, apparent magnitude difference. This leads me to tell you something what is very important. Don't try it, but if you will browse the internet, YouTube, you can find some videos made by good astronomers which were destroying their old equipment to show how powerful the sun is with a piece of paper. And they put a piece of paper to the eyepiece of the, for example, old Newtonian telescope, and in a while it starts to burn. It was a fire. So if you will look with your eye, with your naked eye, without any filter for, let's say, observing sun, you will really destroy your eye. So please don't do it. Your scope is magnificating the light gain, and light means energy, and the energy will really destroy not only your equipment, but can really destroy your eye. And what if you will not have an eye, you cannot observe the universe. So be careful. And here is the one picture I provided you. There are two very common or very known stars. One is the Deneb, I already told you about, which is in the Cygnus constellation. which is apparent magnitude 1.25. And here you can see in some animation how, let's say, brighter looks Vega, which is something like a balance, which has a value of the apparent magnitude 0.03. There is a mistake, but it's 0. So this is a big difference, much more than only, let's say, a little bit, but it's 2.5 point more, and even more because there is a bigger difference. So if you will use some application, or if you will read some astronomical recommendation, and if you will see the number, now you know the higher number means let's say, more difficult observation, especially if you have a small scope. And here I made a list for you. As I told you, the sun is about 27, minus 27, moon minus 12 if it is if it is full moon. And the other numbers for the planets are, let's say, the best apparent magnitude. So if the planet is in perfect condition, as close as possible to the Earth, and let's say with the light from the sun in the perfect position. So the third is the Venus. Venus is minus 492. You can get it if you live on the northern hemisphere, let's say in very early night or later evening. You can get the Venus on the western part of your sky, followed by Jupiter, which is very easily visible. And also now, if you look to the zenith now, you will see the little bit orange or a little bit reddish spot, which is Mars, which is the same maximum brightness, apparent magnitude like Jupiter. And then it goes down. The most bright star is the Sirius. Now it's somewhere like in the southern part of the night sky, and it's very bright star. You can see it's even in minus numbers. Saturn is minus 0.55 in the, let's say, sky like in Prague, which is bottle number 8 or 9. It's almost invisible. And then we will go through the star Arcturus and Vega, which has a 0. Neowise, maybe you remember this comet, especially if you were hunting for the E3ZDF now. So many people are saying, oh, last time we saw the comets, it was visible by naked eye very easily. Yes, it was, because Neowise was the apparent magnitude 1.0, probably, let's say, or let's say within the best dates during the summer of 2020. But you can go down. The E3 ZTF is now about 6.8, which is 2.5 fainter than it was like in the beginning of February. On 1st February, it was somewhere around 5.8. So now it's much fainter. And I was talking about many people even living in Sumava, and I didn't find anyone who was able to see it from Czech Republic from the naked eye. I got some information from the internet, but not from my friends or people I know. So yes, with the binocular or scope, it is possible, especially if you have some dark place. Definitely, even now, because the moon is going to fade from the full moon. However, with every day it will go, the apparent magnitude number will go up, and it will be more faint object for us to observe. And maybe you see there are few colors. The green one you definitely can observe from almost any place, even the light polluted places with the naked eye. I think the breakage where the naked eye is not enough in light polluted areas is somewhere between 3 and 4. Or it depends how old you are and how your eye is prepared and so on. However, 3, 4 apparent magnitude objects are going to be, let's say, almost not visible. Then you have to use your scope with some more light gathering. If you will be on some very unpolluted, so very dark side, maybe your eye will be able to get objects like 6. And I know few people which can really find objects over 7. So it's, let's say, much fainter objects on the dark sky. And yes, there is a one planet, or let's say dwarf planet, marked by the blue color, which is Pluto, which is apparent magnitude 13.65. And you can compare it, for example, with Jupiter. And with Jupiter, it's 17 steps of apparent magnitude. So 17 times you have to apply 25, 22.5 time, 2.5 time, and so on and so on and so on. So I can see that the Pluto is out of your reach of visibility using, for example, the Kowa scope. I think actually the astronomically dedicated scopes like with the diameter of 11 inches or 14 inches are able from pretty dark skies to get objects like up to 15 apparent magnitude. However, it's only theoretical, because if you live in Europe, I think it's impossible. So the limit for the Kowa scope will be around 12, maybe 13, but let's count 12. Everything what is with a high number than 12, it will be invisible for Kowa. If you will use some, let's say, bigger scopes with the bigger aperture, like 15, 20 centimeters, 25, and even more, the number is going slightly up, but slightly because there is huge difference between apparent magnitude 13 and 14. Okay, so this is, let's say, something what you almost can't see, and what you really can't see. So be careful. And this is what I presented you. If I will go back here on this slide with the comets, all of the comets are with the magnitude usually over 15, mostly even over 18. So it's impossible to see it with the astronomical equipment you can buy freely in some market, even if it will be very expensive and very big environment, very big equipment, and very expensive equipment you can get. But this is not enough for the apparent magnitude or brightness, because I will go back here, all the planets and comets and so on, where the objects, let's say, with the one point which is providing you some light. But there is a problem with the objects which are with some surface, which are bigger than only one point, like a star or like the planet. And you have to think about something what is called surface brightness. And the surface brightness can be, let's say, killer for your observation, because it is, let's say, minimizing or let's say growing up, or taking up the number of the apparent magnitude. I got the example for you. This is the Andromeda galaxy. As I make a picture from my mobile phone through the Kowa scope, I think it was a Samsung Note 20 or maybe S22 Ultra, I don't know. However, it's some time ago. And this galaxy is, let's say, marked by apparent magnitude 3.44. But the problem is that this 3.44, which is pretty good number for observation, is something like a total amount of light emitted by this galaxy. And because this galaxy is very big on the sky, if you will use the 30 magnification on the Kowa, the Andromeda galaxy will be bigger if you will have, let's say, enough dark place for observation. So if you will spread this 3.344 for the, let's say, all the galaxy, the surface brightness goes to 22, which means impossible to observe. This picture is made, but it's pretty, let's say, small part of the galaxy, because the surface brightness for the center, for the nucleus of the galaxy, is 8. And you can see the mobile phone. Yes, this is the picture without any stacking. This is a one picture made with some 10 seconds of exposition only, with the, let's say, all the software analyzing and so on, because the smartphones are now a little bit better with the processing of the light gained by the chips than even the professional camera. So after all this, you can get this nucleus with some visible structures. However, this is not the same picture like you can get after, let's say, a few days or a few nights of gathering the light, and then some special procedure with darks and average frames and so on, and then stacking it together with a huge work at your computer. However, be careful when you will read the numbers from your applications or from the website. The apparent magnitude for the, let's say, objects which are bigger than only one spot are usually very mismatching your acceptation, and you can accept that it will be much, much less visible as they are bigger in the space. Here are some other examples. On the left side, you got the Seven Sisters of Pleiades, or Subaru, if you want. This is the Messier object number 45. And the apparent magnitude is 1.6, which is pretty good number. You know, as low number it is, as visible it is on the sky. However, I can tell you, the last time I got the astronomical evening with the people here in Prague, it was for some of the people almost impossible to see Pleiades with the naked sky, with the naked eye on the sky, because of the light pollution, and also because this is, let's say, the star cluster which has some surface. It's not a one point. So from some places, especially light polluted, and if the Pleiades will not be close to the zenith, now during the nights they are, it will be lower to the horizon, it would be impossible to find it with the naked eye, even if the apparent magnitude of the whole star cluster is pretty nice with number 1.6. The Orion Nebula is also the same. With the naked eye in the city centers, you can't see it. Definitely, it's impossible. But if you use the scope, you can see it. You can see it much better. Now here on the picture, it's also the picture from the mobile phone. However, I think this is from the Schmidt-Cassegrain scope, because I used the nebula filter, which is helping to get more color and contrast, because it's allowing only some hydrogenium parts of light structure or to go in. So that's why it's so colorful. If you will observe only visual style with the naked eye, you will definitely see gray color like of the nebula, all the nebulas in the space. But don't worry, if you will put the mobile phone, and if you allow the mobile phone make a 10 seconds or 8 seconds exposure and so on, the colors will let's say go out from the pictures, because you will get more information. Yes, the last example was the Whirlpool galaxy, which is apparent magnitude 8.4. But the Whirlpool galaxy is good because it's not so big. So it's the surface brightness is not so, let's say, is not too much lesser from the 8.4. So it's still in the dark skies, in the dark places, reachable video scope. So you got this 392 quintillion kilometers reach of your Kowa. And something very interesting to finish that part of the what you can see and how your scope is helping you. In the past, like 1000 years ago, it was in July 1054, and we know it because the Chinese astronomers put it in some memories or some chronicles. They saw one star even during daylight. So there was a sun up, there was a bright sky. They saw the star for 23 days. And it was because the one star, a supernova, was exploding the time before the light will come to our Earth. So they called him something like a guest star. The sun had a guest. And after these 24 days, there was a pretty long period, like almost 2 years, very visible star in the night sky. And it was because of this explosion. And now we have a remnant of this exploded supernova, and it's called Crab Nebula. It's very, very interesting. This is a picture of my friend, also stacked from many, many nights of gathering of the light, or maybe it's even from the Hubble, I don't know for now. And yes, if you will go for some dark skies, you can find it because the apparent magnitude is 8.4. So from the city, it will be hard. However, from some outer city or better some darker place, you can find this remnant of the daylight star, which was only once in the human history. So I would like to ask Robert if we have some questions for what we can observe and about scopes.
Nothing. No, we're still good. Everything's ticked off. Yeah. Okay.
Okay. So you can ask the question by the end if you want,
Yeah.
finally, but it's good feedback for me that it's understandable and I would
Yeah.
to make it so. So now what helped me to get pretty deep to astronomy, let's say first is to have a know-how. So uh, first you have to have a clue uh, what you can observe on the on your sky, and there are many softwares you can download to your mobile phone. I'm using two. One I use for observation and navigation, which is Sky Safari. And I think there was some promotional finally for the pro version for last days, but I don't know if it is still going. However, it is something that if you are interested in the sky night sky observation, Sky Safari is, I think, the must to have it, especially if you will connect them to your scopes and you will have a go-to heads, and it will help you navigate and keep the star or keep the object or keep the planet for photography and so on. So Sky Safari is very well. I'm using Stellarium as well because I like, let's say, the graphics for showing the people a little bit more than in Sky Safari. So I kept both of them, but I'm a guide. So if you are not guiding any people or if you are not showing, for example, to your children what you want, I think Sky Safari is pretty good. I like Stellarium for the showing the people more. Uh, these both softwares are very close to, so try it. You can try it for free, and then you can decide what is better. In the third app I'm using very oftenly, when especially when I'm traveling, even in the Czech Republic, or especially when I'm going to Scandinavia or Balkans or even some other continents like in Asia and so on. I'm using this light pollution map because I know where I should go to get the, let's say, the best sky for the night. Yes, this application cannot help you to run out or kick out the clouds. It's not. However, it can help you if if the weather is suitable for astronomical observation. Where is the best spot where you can enjoy more things like in the center of the city or around. What is also fine on this light pollution map, if you will pay it, so you will get a pro version, you can get information about the aurora, which can be good. Yeah, it's very rare in our places like in Prague and so on. However, if you are going somewhere north or if you live there, it can be nice to know where is the chance to, for example, make photos of aurora and stars and so on. So it is very, very good information for you. So these three applications I use. For skies, there are plenty of them, but I think not so good like a Sky Safari or Stellarium is. For light pollution, you can even use the computer application or PC application. You already saw one picture from this. It's free. However, yes, this application, paid application, brings you more information, even about clouds, and you get some terrain information, and you're going to make some notices, and so on and so on. So these three application is something what I recommend to start with if you will go to the astronomical observation. What is also good is to we got in Czech Republic or Slovakia, because it's Slovak based, we got very good book. And now it's time to thank Honza Zahajski, which is a Kowa distributor in Czech Republic, because he recommended it to me, and it's perfect. I like to really read it and get it. And when I'm preparing my scoping evening, or even evening with the people, it's very inspirable. So if you get a chance to get something like a book focusing on the observing with the small scopes, get it. And the perfect way is to connect with someone who is very experienced. It can help you with setting your scopes and looking for some stars and so on and so on. So even after my presentation, I hope I will help you somehow. However, to connection to some other astro people, and to read the books and use the application will be perfect. The second thing, which is very important, especially if you use your Kowa equipment, is something what can help you to align your scope directly to the sky, to the object you are observing, you want to observing. And this is, let's say, a little bit problem with the angle scope. The not angled scope are not good, because if you will put it a little bit more higher altitude on the sky, it's very hard to use it, like to observe it from the down. So the angles are perfect. Finally, angle is not enough for the zenith observation, but I will talk about it later. And with this angle, you are from time to time very, let's say, stuck to find the object. If the object is pretty up and you cannot go from somewhere, for example, like some tower or something what is very visible, and you can go only up, 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 the magnification not allows you to be perfect when finding, especially the small object. And it's then much better to have both eyes open and look through this. This is the red dot finder, so it emits some laser dot. And if you, let's say, align the red dot finder with your scope during the day or even in night, for example, with moon or with something what it's easy to find with the scope, then you can use first your both eyes, find the star, and if the star will be exactly on the red dot place of your finder scope, this one, you can then look to your eyepiece and you will see there, and you will correct it only a little bit, but you will not have any problem to find planet, star, or nebula on your or within your scope. The astronomically dedicated scopes have something like this every time. However, for the spotting scope, the solution is really this Butter Sky Surfer 3 red dot finder, because it's, I think, most or the easiest way how to mount it. And you can see it's only one plate. You put the plate over the plate for your scope head. Here you can see the astronomical head, but I will talk about it later. And there is a Vixen plate. And if you put this red dot finder plate on this, just be careful because of the length of the screw. If the screw is enough, you screw it to your scope. You are only rotating your scope, because you got the you can just set up it with the different angles, your eyepiece, and you put it to the head, and you got the red dot finder, very useful tool for your observation. And after that, if you will use the go-to navigation heads, it will be very important to align the head with the sky, to have an automatical navigation then, which helps you very much. So if you would like to start with your Kowa or with any other scope, I recommend to find the closest dealer with the Butter Sky Surfer red dot finder, which is not expensive, and will help you very, very, very much for your observation and not let you be stuck, let's say, hunting with the angle scope for the sky, especially when the object is pretty high up in the sky. So this is very important. One very, very good things to think, and again, my thank you goes to Supra in Prague for Honza Zaharsky, is this recommendation, which is simply perfect. This is, I think, the smallest automatically navigated head, astronomical head. And this head is perfect because it has a screw for the tripod. So you can see on the picture, I got it on my Gitzo tripod. And it's very small, it's very light, but it's enough powerful to run with the Kowa scopes. It's enough powerful even for my Schmidt-Cassegrain 6-inch telescope. It's up to 5 kilograms. And also what is good, it's very good for plane transportation because it works with the 8 AA batteries. So you can get it out and you don't have a problem with some big head you cannot put into the checked luggage because they don't want to let you have any batteries in. So it's pretty small. It's very, very well worked, and let's say almost all of the pictures are from my side are navigated with this astronomical azimuth altitude GTI Wi-Fi head. It's very easily manageable with the application. The Skywatcher has a SynScan application. It works very well. And if you will have a Sky Safari, you can connect to the Sky Safari through the SynScan. There got some software problems, but they are already solved in the internet, or you can write me and I will help you and will assist you, and you can connect through, and then you can very, very easily use your Sky Safari and run this run this head. What are advantages? You are simply looking to your application and you say, okay, tonight I will go for the Crab Nebula. You put the Crab Nebula, you point it with your finger, and the automatic head will lead your telescope if it will be aligned. Yes, this is the very beginning of your observation every night. It goes to the Crab Nebula, and then you can only put that you can stick with the object, with the Crab Nebula, and after half an hour you can show it to your mommy or to your children or to your wife or what you want, so it can keep there. And also you can do the pictures, but be careful because there are two kind of heads. This small one is azimuth altitude, so it goes like up and down and horizontally, which is not the perfect solution for long exposure astronomical photographs because the let's say the sky is rotating, and this is not rotating, it's going only up and down and left and right. So let's say there are some limitations, but for phone astrophotography it can be okay for many situations, like I will talk a little bit later. So this is perfect because it's light, it's very packable, and it works very well for all scopes, especially Kowa scopes, which are brilliant. One reminder, do not forget to have a red light head torch, because with the red light, you will not destroy your ability to catch light for your eyes. And now I will answer the question we already get, which is concerning the astronomical eyepieces. Yes, Kowa is, I think, the only one producer which produces the special adapter rings, which you have a two for choice. One is with the big screws on the left side. This is astronomical piece with the K at the end on the part number. And one has a screw inside. This is a right side with the screws a little bit hidden in the adapter, which has a G by the end of the product number. And these two adapters are for, let's say, different astronomical eyepieces. If the eyepiece is long enough, so it means the number, like here you can see the teleview eyepiece, which is 6 millimeter. If the number is low, like 6, 5, 4, and so on, it will be usually enough with the K, so the left one adapter, and it's a little bit more easier because you put it very easily into the scope. Yeah, you have to take out the original eyepiece for sure. You put it, you screw it to the scope, and then you put only the eyepiece, and you use the small screws, and you got the eyepiece with, let's say, longer or bigger magnification. In the next slide, I will show you how big it is. If you will have eyepieces which are, let's say, more wide, so higher number of the millimeter focal lengths, like 10 and so on, it can be impossible with this K adapter, and you will need this G adapter, which goes a little bit closer to the optical system of the scope. And because this spotting scope or spotting scopes at all have a short back focus, which means the light is, let's say, going to some another optical elements closer after the last lens than the dedicated astronomical scopes. So be careful. Check it with your local dealer. Your local dealer should have some compatibility list. I already checked this Teleview Delos 6 millimeter. It works, but even in the same product line, it wouldn't work even with the G adapter. If you will use, for example, like a something with the, let's say, wider area, like 18 or something like this. So be careful and check it, test it before you will buy it, especially if you buy such a expensive. The Teleview eyepieces are, let's say, one of the best or best maybe in the world. So if you use Kowa, you will definitely not put there any cheap eyepiece from the astronomical world. And here is my setup I'm using for now for the Kowa scoping. I'm using very often the TE11WZ2 series with the magnification 30 times to 70 times. This is something like a basic astronomical Kowa eyepiece. For the pictures, I'm using 40 times, so this is a TE80 XW eyepiece, which is simply brilliant for making any photos. It's the sharpest eyepiece I have ever seen all over the world and all over scope world. And if I want to have a, let's say, higher magnification, I'm putting the K adapter, as you can see on the picture, and I put the Teleview 6 millimeter Delos in, and I got the 97 magnification. And this is, let's say, for the planet, if you get a good seeing condition, it's very, very good eyepiece. However, you can get to 100 even without these astronomical eyepieces. If you put the extender with the brilliant Kowa extender 1.6 times, with the TE11VZ 2 series, you can get 48 to 112 magnification, which is perfect. And to be honest, if you will, let's say, observe from most European places like towns or around towns, it will be hard to find a night with the possibility to go with the magnification more higher. Okay, with the Teleview and the extender, you can use it together. You can go up to 155, but I think in last year I used it effectively and, let's say, with nice observation only twice. So only 2 times, and I did a lot of observations. I used such a big magnification. And I'm talking also about using my Schmidt-Cassegrain, which is, let's say, providing a bigger light gain or higher light gain. And also I'm using, let's say, more astronomical eyepieces. I'm usually sticked with the more wide providing, let's say, more context in the dark sky, and it's usually much better observation than going up with some crazy magnification. Finally, there is one website, but I can't remember now the name exactly, but you can let's say prepare how big the object will be in the eyepiece. You can put your scope, your focal length, and so on, and you can put the eyepiece, and then it calculates, let's say, your view. So you will have something like a virtual view through your scope, and you can see how big the object will be, and then you will see that the difference between, for example, 70 times to 90 times is not that big. Even the 120 to 150 is not that big, let's say, difference, especially for the small planets. It's still small in your view, but if you magnify, even the problems with seeing, your observation will be worse with the more magnifying eyepiece. So be careful. And I think if you will use your Kowa 11, TE11, or if you got the T80 XW, it's perfect. Definitely for most of situation, it's perfect. With combination with extender, if you want to have some pictures. Uh, what is really important, and don't forget about it, if you don't have good enough tripod, you will have big problems, let's say, especially if you want to do some photography, but also for the visual. And I also can recommend to go as light white as you can. And I'm using a long time the Gitzo, which is, I think, the best investment you can do, even in comparison with some cheaper carbon based tripods, because if you break any part of Gitzo, they are changing it in 1 month maximum, maybe even less. So you have a spare parts for I don't know how long, for as long you want, because they keep it for their clients. So it's perfect. It's lightweight, and if you put the go-to hat on this, it's still very lightweight, so you can go anywhere you want, even for long trekking for some crazy place far away from the civilization, with the perfect dark skies in the mountain, even in Himalaya for sure. So don't forget the tripod is a very important place, and very important equipment you have to talk about. Finally, the go-to hat, the Skywatcher go-to hat, is usually sold with a tripod, but the tripod is so crappy that I am not using it. And by the end of this equipment, I got something, let's say, to think about, something for Kowa for sure, because I will tell you something about the second disadvantage you will have when you will use spotting scope for the astronomical observation against the dedicated astronomical scope. And this is the angle of your eyepiece. uh, I already told you that the best observation condition for the object is as much to zenith, so upwards. So you have to look as up as possible if you want to get the best views or best photographs. And try to imagine you got these two scopes on your heads. It's very easy to observe, let's say, the dedicated astronomical scope like this Celestron, because of this 90 degree angle. In comparison, you have to make some exercises, or have some special, I don't know what, some lie or something, or change the position of the tripod to be, let's say, somehow comfortable with observing with the Kowa. So maybe you can use some adapter providing additional 45 degrees, but till now I haven't tested it. So this is only some idea, maybe idea for Kowa to make some, which can be also ready for the Kowa eyepieces. it will be brilliant if it will be so. However, I know it's, let's say, some development, and it depends how money it will cost, but it will really help anybody to observe and use 100% optimal scope as a astronomical scope for the Kowa. So this is only one thing you will face if you will use your Kowa scope. However, you can survive it very easily. It's not so bad. It will not break your observation, but you will have some better muscles on your legs for sure. And also be careful. One more thing, when you will use the eyepieces, you have to have very good eyepieces which fits on your eyepiece, because they are going down, and the gravitation can, uh, let's say, destroy your phone even if it will fall down for some concrete and so on. So be careful and use very high quality eyepieces, adapters, phone adapters for you. It should be really sticked on the eyepiece. One more thing about the adapters or phone adapters, there is really, let's say, bad situation about phone adapters for the astronomical eyepieces, especially with the eyepieces looking like this teleview, which are not, let's say, the straight narrow like the Kowa original eyepieces are. So you cannot use any adapters like, from PhoneScope or Varioscope, the Smartoscope, or Nova Grade, and whatever. I tried to manage it with the Celestron, which is very bulky, big, but it's so, let's say, badly made, and it's shaky, and you cannot fit it. So it's really hard. So it's, let's say, more, let's say, training your nerves than enjoying the photography. But now I've placed an order for some other manufacturer. It's also some Chinese, but two of my friends said that this eyepiece is much better. So now I'm waiting, but till now I can't say I found the solution already. However, if you will use the Kowa eyepieces, you can use your adapter you already know and you already own, I think. So this was about the equipment. It can help you. I will again ask Robert if we have some questions.
Just the one we've got. Do you have any experience what astro eyepieces work with the adapter? I'm assuming that's the astro adapters. I'm using the Pentax XW10 and 7 in combination with the 1.6 extender.
Yeah,
And I am using the Teleview 40 times Plotty without converter, and the Teleview 4.7 Ethos without
yeah.
converter. Are there anything else eyepieces recommended?
It's hard to answer because I tried like a 7 till now, and only 2 Deloses worked very well. I know the Pentax is working well, but I don't know if it is whole the line, okay? Because even for the Delos, it's not the whole the line. For example, the 14 millimeter Delos, which is perfect eyepiece, even with the G adapter, is going very close to the infinite focusing. However, it's not enough. It's something like a half of the percent is missing. You are very close to, you can observe, but you will not get a sharp image for sure. So
Yeah.
there is some limitation for all eyepieces, and it should be tested. And I recommend to, let's say, get in touch with the local astronomical dealer and go there with the scope and try it. It's the best way, okay? Because finally, if you buy the astronomical eyepiece like a Teleview Ethos it's very expensive. It's very good, but very expensive. Yes, you have to have you have to be sure that it will work for you.
Yeah.
Otherwise, what you will do with this?
Yeah. If you go on to just another point, if you go on to kowaoptic.com and then just browse to the 2 astro adapters, we have recently put a
Yeah,
PDF up there with some of the popular eyepieces that have actually been tested. So that could be a good starting point too. When we put this video on YouTube, we'll put the link in, and hopefully
okay,
that
okay,
will
this
help.
is perfect.
Yeah.
Finally, guys, the original eyepieces from Kowa are brilliant. So for 99% of observation and pictures, you will definitely use your Kowa eyepieces. So the 11 VZ and the 80 TW or XW, which is the 40 times, these are brilliant eyepieces, especially if you got the adapters for your phones. And for astrophone scoping, they are perfect. Okay. So only for the, let's say, higher magnification, you will use the let's say the shorter eyepieces like 6 mil and 4 mil or something like this, but not so often. So back to presentation, I thought it will be 1 hour and something, and now we are almost 2 hours. So I will go pretty fast through the photography part. And I already told you, this is something what can be pretty big and deep rabbit hole, especially for time and money. And I will explain it later. These three pictures, what you see here is made by phone and by Kowa scope. And you can see on the left side, the moon. This is pretty good photo, I think. This is enough sharp. With some post-processing, you can get the colors very easily. The only thing you have to know is, let's say, something about exposure, because the moon is so bright that you have to go with the exposure down. And that's why I'm using the Samsung smartphones, because besides I can use the S Pen as the remote control, they got the Expert Raw application, which is combining very good chip with the some technology software, which is providing something like a more exposure, and then combining them together and providing very high definition prepared data from such photographing and in the raw format. So then you can do what you want with this. So if you are Android on your phone, I strongly recommend some, let's say, good S-line Samsung to use the Xperia. Or if you got the Note 20, I think it's also ready or suitable to use the Xperia, and you can use and produce very good picture, especially for the moon. And moon is very good. It's if you will observe it, you can observe it for a few hours and then change the position and find some craters and some seas and so on. Maybe you can even find some American astronauts on there, but I'm joking now. So this is for the moon. On the right side, you get the Jupiter, and this is not the best Jupiter photo I made. I got much better, but this is something from the very beginning. However, this is not the one shot photo, because I studied at the internet something about the stacking, and for the planets, I get the recommendation to take a video. It was like I don't know, 20 or 30 seconds video. And then I used some softwares, which first cut it out the frames from the video, then it controls the quality, and then you pick up the only, let's say, the best quality frames. I didn't control it well. You can see it, and that it's a little bit blurry. And then it stuck it together and went with the details, which is another software. And the last software corrects the contrast and so on, and you can get the planet. However, you will never see this planet like this in your scope for visual, because it's impossible. This is only when you start to photograph it. But you can see this is made by mobile phone. We are talking about a mobile phone photography for the object, which is more than 600 million kilometers away from Earth. It's not a bird, it's not a bear, it's not the, I don't know, tiger. It's something very far away. And the last picture I'm presenting here is the C2022 E3 ZDF comet. So this is the comet we are observing now everywhere. And this is a one-shot picture also made by Kowa. I think it's something like this is 14 or 15 seconds exposure, but it's well, it's it's tracked by the astrohead you already know from the Skywatcher. And as you see, this is azimuth altitude head. It's not the equatorial, which is, let's say, correcting the star trace well. But if you use in, let's say, reasonable time, you can get the stars like circles, especially if you then present the picture on Instagram or Facebook, which is everybody checking mostly on the mobile phone. It's okay. However, within astrophotography, you can be easily on the fork road, and here on the left side, you got pictures from my friends, and you can very easily see the difference between what you get from the phone and what you get when you will stay in the night, like few nights, and will get a lot of data, and then you will stack it together. Yes, uh, we are still talking about big difference, and these differences are this: you will spend a lot of time capturing the data. Okay, so gathering the light for some pictures like this is the Horsehead Nebula, which I love, with the Flame Nebula. You can see the Horsehead very easily. It was like, I don't know, 10 or 12 nights from the information of my friend. 12 nights collecting the data. And then it was like also night, because he's not a professional photographer. He has his job. A few nights processing it with like 5 softwares and tuning in and so on and so on, and stacking and destacking and so on. It's crazy. It's crazy. So if you live the office life and you are using your PC, you get the additional PC time for this kind of professional astrophotography. If it will, you, let's say, plan it to make it serious and for a long time, it will cost you fortune for sure. Yes, you can start with even your mirrorless camera, for example, with only one small head. But I don't know anyone who ends with this setup. Usually there are like scopes, another scopes, and they are very high quality and with a big aperture and so on. And these are, let's say, thousands of euros or thousands of dollars spent on this. And honestly, I will tell you, I will spend them for traveling. And it's, from my point of view, it's much better than to put it to the equipment, which is very, very hard then to travel with. And it's really sticks you into or at one place, and also to computer. This is one thing. So yes, you can go for a much, much better picture than you have seen here on the right side, for sure. However, it will cost you and you will pay for it for sure, these 4 things I mentioned. And if you will not, you can go, if you have a clear sky, like after 10 seconds, 10 minutes, sorry, take your Kowa or take your scope and point it up to your skies. And with the one up, you can download in 1 minute. You can have some idea, and then you can buy only a few things like a small head and a small red dot finder and so on. And you can observe and photograph objects hundreds of thousands or even hundreds of millions kilometers, or even more, even the quintillion kilometers, as I already shown you, away from you. And I think this is something what is exceptionally inspirational, especially for me. Yes, I love to search for cats and for snow leopards and for pumas and for lynxes, and I like phone scoping for this and for birds and for owls. However, I would like to have like 100 more years in my life to, let's say, hunt a little bit all the inspiration you can get from the space. And the Kowa is enough. It's much, much, much better in comparison with Galileo Galilei, which is who saw the Jupiter moons, 4 Jupiter moons in 18th century or 17th century, sorry. So you get much better equipment, and with the phone you can photograph it. And finally, this comet picture I made in the center of the Prague. So there was a completely crazy border, and I managed it like this. And the last astro event I made, I announced like 1 day before, because we got something what we call window in the weather. So it was like a few days without any clouds, and I got like 2.5 hours of line waiting for my scope to look at the sky for this faint object. But finally, it wasn't such nice and such a green for visual observation. But yes, you got so many opportunities to show to your children, to your friends, or yourself, and enjoy it. So don't worry about some better picture or better equipment. You got your scope and you can use it. And by the end, I will provide you a few hints I found for the last 1 year. I'm really, let's say, deeply focused in astrophone scoping. uh, don't worry to use the telelens on your mobile phones for the planet and moon. You can get a pretty brilliant details, especially with the S22 or now 23 Ultra, or S21 Ultra or Note 20. You got very, very good telelens cameras you can use, and it can magnify the planets for you. But be careful. Remember, the magnifying can bring you even some defects for your photos, because it magnifies even the seeing problems. However, if you will hunt for some fainter objects like these nebulas or galaxies with apparent magnitude more than 4 and even more, you have to use the main lens, because otherwise you will not get enough data and it will be invisible for you. However, now the technology of the mobile phone is so good that you don't need to exceed ISO 800. My experience is that over the ISO 800, you're getting more problems than more light. And most of the pictures are made like 640 or 800. Once 1600 from time to time, but it's really rare. And just keep in mind that if you will use your, let's say, phone scoping from the untracked head, so there will be no assistance to move and keep the object in the same place. Your exposure time should not exceed more than 2 or 4 seconds from time to time. If you will have the head I already presented to you, so the Skywatcher altitude azimuth head, the limitation is somewhere about 15 seconds. From 15 seconds, you will get the star trails. So now the shape of the star will go more like something like problems. And if you will have the equatorial, but it's usually much bigger, and the setup is a little bit more difficult, you can go even for minutes. Okay, so if you will decide to go more deeper for astro photography, before you will buy some special scopes or special cameras and so on, buy a good equatorial head, equatorial mount. This is, I think, the first very important step, and then you can keep like 1 year even with the Kowa and in the mobile phone, and you will get much better photos. This is also for me something what I am thinking about. Now I am, let's say, saying greetings for Hans Zahajski, because I will visit him, and we will discuss some small transportable equatorial head I will add to my portfolio, because I want to make nicer pictures of the nebulas. And if you will go for the planetary, really try to make a video, especially if you will have the tracked setup. So if you will have some go-to head which can keep your, for example, Saturn or Jupiter in the frame, so you can have even like 40 seconds, 1 minute, and if you then put it to the EIPP software and then AutoStacker and Registax, you can get really nice result, and it will not cost you more than, for example, tens of minutes or maybe 1 hour, but you will not spend like hold the knife all many nights stacking some crazy pictures. So this is something what I can recommend you, and it can, let's say, result in much better pictures. There's only one click and a few seconds of, or even not the seconds for the planetary. Uh, there are also some easy way how to stack, not for a long time or not with not so, let's say, time invested for deep space, but this will be also for some other presentation. And now we are going to 2 hours, so it's pretty long. So you can check it. YouTube is full of tutorials, so definitely you can check it. Or again, ask someone who is experienced, and he will tell you. Finally, the PIPP and AutoStacker and Registax are free software, so it will not cost you anything. And I think even for the deep space stacking, there are some softwares which are free, made by, let's say, fans of astrophotography. So this was my, let's say, last recommendation. And for the very end of the presentation, I got the one inspiration for you. If you will open the list of star systems on Wikipedia, you can find some star with the same number of light years, same distance in light years as your age is. And if you point on such a star, you will see the light which was born in the same year, very close to your birth. So you will find your birth star. It will change every year for sure. And be careful if you will check the list. Some of the stars are observable only from the south hemisphere. So you have to check with your application, like with the Sky Safari or with the Stellarium, if it is visible. And don't forget that the apparent magnitude is also killing some stars for observation for you, especially if you want to observe it, for example, for the balcony in the city. So keep in mind that the star should be something like up to 4 or 5, then it will be very, very hard to find. But it's a fun. It's a fun for children and for naive people, not, let's say, not wet in the astronomy. And you can make a lot of fun during all the night. Last time it was the 31st December. We started to observe from my friend's garden, and our program till the very beginning of the day, 1st of January, besides like 20 minutes of the fireworks, was observing stars according to age of the partiers. So it's very fun. So you can enjoy it. So friends, my last words is have a clear sky. Definitely, if you will buy some scope or any equipment, there will be like 2 months of clouds for sure, because this is how it works. However, wait, be patient, or use your car or use a plane to find some better places. And if you want to discuss my experience, or want to have some advice, or anything concerning my guiding for snow leopard, pandas, and lynxes and so on, you can visit me on the Facebook, which is flyfish.cz, or Instagram, the same flyfish.cz. I recommend the English speaking go to Instagram, because I keep it in English and let's say Slavonic languages for Facebook, but I can answer you, don't worry. Or you can get some inspiration on my website, my guiding website, www.flyfish.cz. So thank you very much. Sorry for the 2-hour presentation without any Kahoot interaction. However, I hope you survive it. And my last question goes for Robert, if we have some additional question now.
We do. A couple more questions. Without a longer exposure photo, does the comet E3 just look like a fuzzy cloud when you observe it with the eye? If this chap thinks he saw it with his 770 scope, but it doesn't look anything like a photo.
We are talking about visual observation.
Yes, compared to the details that you can capture with a photo. So,
Yes.
does that comet literally just look like a fuzzy cloud if you were to look through it? the telescope?
Yes, if you use only visual, so you only use your naked eye, the comet is something like a one light in the middle and yeah, fusing something like a nebula, okay, small one. But it's interesting if you are not sure what you are looking for, uh, find it once and then wait something like a few half an hour, for example, and if it moved from the position between some stars from another position, it's definitely the comet because the comet is flying. So I think the speed is 60 kilometers per second. So the comet is changing position. Let's say comparing with the sky chart. So definitely this that kind that way you can recognize the comet against anything, something like cloud or fog in the atmosphere, so on. However, for visual, yes, it's not a neowise. I don't know if you remember the neowise comet in 2020, but it was very observable even with the naked eyes. And if you remember from my presentation, I will maybe share it again. I got the pictures which were made, uh, but I have to go back. Sorry. There were some picture made with only mobile phone. Yeah, it was here, I think. Yes, here. Here are the pictures. The right side is the mobile phone picture, so without any scope. So you can see the Great Dipper, and a little bit underneath is the comet, which is very, very nicely visible. And finally, it wasn't any special phone that way. I think it was some old Sony I got with me. And yeah, the second picture is the neowise through the Kowa scope. But I think I did a picture without any adapter then. So
Right.
this is the difference.
Yeah.
However, yeah, optical or visual observations, yes, they are a little bit worse than what you can get from the mobile phone. So if you got the mobile phone and if you got the adapter, so you are the phone scoper already, it's very easy to make a picture and to get more from the space because the technology and the chip is much better than the naked eye, for sure.
Yeah.
I'm
And then
presenting it all the time. If you know the phone scoping group, and every month when I'm going with clients to do some all trips, and I'm making photographs for the alls with my mobile phone. Let's say 20 minutes after all the people with the pro cameras like the Sony Alpha One already packed it to the luggage. Okay, so yes, the mobile phones now are very good, perfect tools to get more from space, for sure.
and the last two questions, which are kind of connected in a way, and talking about mobile phones, is it the Samsung S23 you're currently using?
Yes, but it's I think 1 week and something only. So now I'm
Right,
using
right.
S23 Ultra. Yeah.
Yeah, S23 Ultra. And another question related to phones is the S22 and the S23, they're your sort of go-to phones. The question is, are they easy to handle in terms of the size and weight? Do they put any strain on the eyepiece? Do you have any problems? Because they're quite big phones, aren't they?
Yes. If we talk about ultras, because the S22 or S23 without ultra is pretty good concerning size. However, the ultras, which are, let's say, with much better cameras, and especially S23 with the 200 megapixel chip, which can do binding like 16 pixels together, and it's really magical what it provides. Even it's very beginning, and it will be balanced softwarely for sure with some updates. However, yes, it's pretty heavy because yeah, it's really ease of equipment. You can see it, it's like my head. If it will be more durable here, you can use it for paddling for sure. However, if you got a good uh, adapter, it's not a problem. Okay, I'm using two. I got the smartoscope, especially if I'm changing all the cameras, because the let's say the 10 times telephoto camera it's out of the reach when I use my older Nova grade. And the smartoscope is perfect because it's well done. It's metal and it keeps on place with no problem. Nova grade is a little bit better without the grip because it has a special screw type which you can tighten very, very well. And yes, but then I can use only the main camera and the 3x telephoto because there is no reach for the camera so far from the edge of the phone. Yes, so but you have to have, if you have a good adapter, you can do anything what you want. And for the astronomical adapters, which are not so, let's say, narrow one, and you have to have a different kind of adapters, I will check. It's from Move Shoot Move company. And yes, the recommendation from my friends from the United States are perfect. So I'm waiting for it. I already paid it, so I hope I will get it in like 1-2 weeks, and then you can send me a message and ask. And it should be suitable for astro IPCs. And yeah, it's not so convenient like a smartoscope or Nova grade, but it should work for IPCs. And it's not let's say piece of crap like the Celestron QYZ or XYZ adapter, which is suitable, yeah, for moon photography maybe, but let's say for the fainter object it's too hard. It's really not good engineered and not good done. It's plastic and it's wobbly and shaky, and so it's not good. I don't recommend it.
Yeah. Well, what to say really? I mean, thanks ever so much, Martin, for the time to take, your evening out. So I had no idea just in depth your knowledge was. Just viewing the night sky astronomy. It's just mind blowing, really. I knew that you were into the wildlife and the digiscoping thing, but wow. I mean, this webinar will be on our YouTube channel because I think this is this kind of webinar that you can keep dipping back into, isn't it? Go through and
I hope
find
so.
different sections. So we'll put that up on the youtube.com/Kowa Sporting Optics. We'll get that on this week, and maybe we should do a deep dive astro digiscoping webinar sometime later on in the year where you sort of go into a bit more detail about some of the techniques that you're using and things. I mean, like you say, you could talk for at least another 2 hours just on those, just on
Yes,
talking about that.
concerning stacking and all the things like concerning softwares. But for the first time, let's say for me was describing how to, let's say, dive in without spending huge money, which is not effective, or having so much frustration around because not understanding the basic things. So for now it was
Yeah.
like this. For stacking and software things, for me it will be hard because I really hate it. I love to use the phone scoping because when I'm making the picture, for example, Puma far away in Patagonia, and in 10 minutes I am making it with the Adobe Lightroom on my mobile phone, and I'm sending it to people or for social networks and so on. So I don't really, I don't love to sit by the computer and do such a thing. So I hope Samsung maybe will find some way, and they got some astronomical modes in expert raw application for now, but I didn't test it too much, especially in the S23 Ultra, because there are some artificial intelligence which is stacking photos in the mobile phone. So it's nothing what you have to do, but it's done by some software and artificial intelligence and some auto learning machine and so on. So we will see, and definitely in the future it will be so easy. However, for now it's, let's say, Hitsun Leonis area, so I don't know how it works. I didn't test it so much, so I can't explain it to you or any friends.
Yeah. Great. But so yeah, so we'd love to have you back again later on in the year when you've got some time, and for another fascinating webinar. We've got another webinar coming up in March, which is the totally different subject. Jeff's put together a Kowa scoping team for the Champions of the Flyway in Israel. So we're going to get some of the teams together and just chat about what what the Champions of the Flyway is and what's going to be going on. And we're going to enter a unique digiscoping team. So that should be quite interesting. So that'll be on the 6th of March. So there you go.
Okay.
So thank you once again, Martin. That was absolutely fascinating. Yeah, I think I must.
You're welcome.
Yeah, I'll get out there with the scope and just looking at the moon is just amazing, isn't it?
Yes,
It's just you get a good clear sky and just just go for it. So great.
Okay.
Well, thanks very much for your time again. And yes, and keep your eye out on the Facebook and YouTube channel for more webinars. And see you soon.
Yes. See you, and thanks every attendee to listen such a long presentation. Bye-bye.
Bye-bye.
And look up.